Hi, I'm Syd from Sentry. I work here. I'm going to talk today about how we built a flexible and real-time data warehouse here at Sentry using Beam and Dataflow. I'm Syd, and I use they them pronouns. So here's some background about the problems we were trying to solve. Here's some background. I meant to remove this, but this is a background about Beam and Dataflow because I gave this presentation elsewhere. So I'm sure you all already are familiar, but Beam is an open source framework for processing both batch and streaming data. It generally takes data, transforms it in some way, and then outputs it somewhere else. Dataflow is a product offered by Google in the cloud that allows us to execute these Beam pipelines. You may have also heard of Spark and Flink. There are other examples of ways to execute these same Beam pipelines. So another way to explain this is with a diagram. So we have batch data or streaming data. It feeds into a Beam pipeline and goes out to some output somewhere. The pipeline is executed by Dataflow or by Spark or Flink or whatever technology you want. So I'm going to talk about the projects I've been working on now. I've been spending a lot of time working with Beam and Dataflow. In particular, there were two major projects I worked on. The first was using something called change data capture, or CDC, which I'll elaborate on in a moment, to reconstruct basically production Postgres tables in BigQuery in real time. The second is streaming something that we at Sentry call events into BigQuery, and then finding a relatively inexpensive way to query like a lot of data. So first I'll talk about this CDC change data capture project. What does this mean? It's a Postgres extension, which is actually open source. And it's essentially a Postgres change log. So if something is like updated or inserted or deleted, like it'll log like what changed, what table, stuff like that. That's a link to it in open source if you're curious to check it out. It's really cool. Why do we want to do this? So Postgres is our production database that we use inside of our application, and our application talks to it. BigQuery is what we use for analytics. Frankly, we don't want to run our analytics directly in Postgres because if we write a big monster query and it takes too long, it'll break Sentry, and we don't want that kind of responsibility. So we move all of our data into BigQuery to run analytics and expose and looker and all the stuff that we want to be able to do internally. So our old solution was to like hourly replicate these Postgres tables into BigQuery, like on a cron job. It was called PG to BQ, Postgres to BigQuery. But as these tables got bigger, this replication got slower and slower. Eventually the jobs became too slow to run every hour, so we started running them every 4 hours, and then our data was constantly out of date. Any delay in replication meant a delay in action. So if we wanted to send an email to a new huge customer that signed up, we might not know that they signed up until 4 hours later, and then it's not very actionable at that point. So by tracking these changes in real time, we're able to keep these tables in BigQuery up to date with the tables in Postgres. So this is kind of an example of how this would work. So say a user interacts with our product on our website. Based on this interaction, a row is written or updated or deleted in Postgres. And then after that row is updated, the CDC extension pushes some data to Kafka, representing the change. So like what table did it affect? Was it an insert, an update, or a delete? What are the like new and old values in that row? Like basically what changed? So at a high level, this is what I'm doing after the changes are sent to Kafka. I wrote a consumer that does a little bit of formatting and filtering, and then it throws them into PubSub. And then I'm using Dataflow to consume from PubSub, do some more formatting and data transforms, and then write it to BigQuery. So let's look at the structure of my Dataflow project. The first step is it reads this data from PubSub, and then it formats and writes to this all changes table. I thought it was important to kind of keep a log of all the changes that they came in. It's not very usable in this state, but this is kind of like, if anything breaks downstream, this is a good place to debug like what the change looked like, why did it break stuff. And then from there, I'm actually breaking out these changes into like what table was affected by the change. The formatting step here is a little bit more complex. I'll talk about that in a moment. But basically all the changes for the organizations table go to this like organization specific change table. Same with users and all these different tables. And we're actually taking advantage of Beam tags here to make sure that like only the changes for like organizations, for example, only are processed in this step and they're not processed in all those other steps, because that's just like duplicative work. So let's look at this structure of this all changes table first, where we're writing roughly the same data that we get from PubSub in roughly the same format. Again, we're not directly querying this for any reason in BigQuery. It's basically just here if something goes horrifically wrong, so we can problem solve. So first we keep track of, again, what type of change this is an update or a delete or whatever. We also keep track of the timestamp of the change. So this is like literally like at what time in our Postgres database was this change triggered. This is really important because without it we don't know what time or what order these changes happened in. And then we also keep track of what table it came from. So is this the organizations, was this a change in the organizations table or in the users table? And then these columns that we get are actually really messy. We get like an array of all the column names in that table, and a corresponding array of all the column types in that table, and then a corresponding array of all the values. So you can see now why this isn't very usable data. It's really difficult to work with. It does contain all the columns for this table, so that's helpful in reconstructing the tables later, as you'll see. So now, like in the next step of that data flow breakdown that you saw, we're going to format specifically for each table. So this is an example for the organizations table, but we do the same thing for like our users table and our like issues table and all this stuff. So it's pretty similar. We keep track of the event type and the timestamp. But this time we break out each of those fields individually. So say the organizations table has an ID field and a name field and a date created field and all this stuff. We actually keep track of separately. What happens if our schema changes here? That's a big to-do. We don't really know. It honestly happens infrequently enough right now that we can kind of deal with it manually and add rows to the table or add columns to the table as necessary, but this is a big gap in this project, honestly, and this is a big thing that we have to figure out how to do in the future to make this run forever by itself. So now we have these raw updates in BigQuery. How do we actually construct these into a table that we can query like the Postgres table? Our first thought was to actually apply the DDL to BigQuery and like actually insert these rows, update these rows, and delete these rows. However, BigQuery has a ton of limitations about what you can do. Their quota is actually really low. It's like 10 updates per second per table or something, which like our change volume is just much higher than that. So there are many ways we probably could have solved this. I chose to solve it with SQL because I like working with SQL. So I'll kind of elaborate what this SQL view looks like. I'm not going to actually show the SQL because it's really long and really messy, and you don't need to see it. But I'm going to kind of go through like a pseudocode approach, like what we did on a high level. So for each like primary ID in any of these tables, so organizations for example, we're going to take the row in this raw change table with the max timestamp to get its current state. And as I said earlier, each row contains all the columns for the table. So whatever, at any point, whatever the max timestamp row is represents the current view into that ID, if that makes sense. So this is an example of kind of what the raw change table might look like. There are a lot more fields than this, obviously, but you can see we have like an ID, a name, a last edited, which is where the difference is between these two rows, and then a timestamp. You can see the second row is the more recent row, so this represents the current view into the data. Just a quick note, if the most recent change is a delete type, we have to handle it slightly differently. This is an example, so you can see similar, but one of these is a delete and one is an update. The delete happened more recently, so we're just going to exclude it from the final result because this row has essentially been deleted, so it shouldn't appear in the real-time view of the table. We did it. So this is on to my second project. It's an awkward transition, but it's okay. So yeah, we're going to talk about my streaming events project. But first I have to talk a little bit about what is Sentry. I started making these slides and I realized very quickly that like this project makes no sense if you don't know what Sentry does. And I don't expect all of you to know what Sentry does. So let's imagine that you installed Sentry on like your application or your website or your mobile game, and your code breaks, because it always does. an exception is thrown, you can't avoid it. What happens? So some details about this exception appear in Sentry essentially immediately. You'll get an email or a Slack notification or a Jira ticket or like however you've set up Sentry to notify you. And then ideally you fix the bug before a user even reports it. So someone writes into support, hey, I had this bug. You can either say our engineers know and they're working on it, or a fix has already been delivered. It shouldn't happen again. So what happens on our side when an exception is sent to us? So let's say you get an exception in your app. It comes to Sentry. From here it goes into a Kafka queue, and then it eventually makes its way into a production events database called Snuba. This is different from the Postgres database that all our tables are in. All of our our Postgres tables are in. That's because this event volume is just so high. Postgres was not a good solution. You can read more about Snuba and why we made that decision on our blog. It's a really good blog post. However, our analytics, as I said, shouldn't query Snuba. We don't want to take down Sentry. It's too dangerous. So we need to find a better way to do analytics on this data. This is going to look like a really similar pattern. That's because it is. Basically, I have a consumer going from Kafka, throwing those events into PubSub, and then Dataflow is bringing them into BigQuery, where analytics can happily query. Except we can't really query it, because Sentry stores about 2,500 events per second. We receive actually many more than this, but a lot are discarded due to like rate limiting and a bunch of other stuff, customers filters. So this is like around 6 billion events per month. Which if we try to query it directly in BigQuery, it's like really big, it's really slow, it's really expensive, it's like essentially unusable, especially as we keep track of this data over like months or years or whatever. So our solution so far has been to craft like many aggregates of events that have common attributes, which allow us to flexibly answer questions while still not querying quite so many rows. It's a lot faster, it's a lot cheaper. But what does flexible here mean? My first thought when I came up with this project was aggregates aren't very flexible by default. You can't really drill into them. You can't really see what each event looks like. So to us, this means that we're crafting a solution where we can easily add a new aggregate at any time, and we are storing the raw events still in BigQuery, so we can easily backfill that aggregate to answer a new question. So if someone comes out of the blue and asks us like, hey, what about this? And we're like, we can't answer that today, but let me do an hour or two of work and then we can. So to do this, we want to use Dataflow's streaming ability to backfill these in real time. So like every 5 minutes or whatever windowing we want to be able to roll these events up in real time. And we also want to take advantage of Dataflow's batch functionality to backfill when we create a new aggregate. That's still on our to-do list. It ended up more complicated and confusing than I had anticipated. So for now, we're using Airflow to aggregate these events hourly, so it's not quite real time. But we still have the advantage of every single event going back historically, so we can backfill. So we get the same flexibility that we have from the backfill. It's just hourly instead of every 5 minutes, every 2 minutes, whatever. That's pretty much it. So to summarize kind of what I've talked about, at Sentry we use Dataflow to have access to real-time data that we didn't have before. So for example, we use it to reconstruct Postgres tables in BigQuery with essentially no replication delay. And we have events in BigQuery in real time. Eventually we want to use Dataflow to aggregate these similar events together to make queries easier and cheaper, but we're still getting there. But that's our next kind of to-do on this project. So hopefully these examples give you new ideas about how your team can leverage a powerful tool like Dataflow. Thanks for listening.
Other questions?
Yeah, a question. You mentioned that you're using Kafka and PubSub.
Yeah.
Why can't you just use Dataflow connector to connect to Kafka?
Totally. So in both of these cases, both for CDC and events, there are certain types. So for CDC, for example, there's certain types of changes we don't care about. There's certain tables that we actually don't care about replicating in BigQuery if they're not useful for analytics. So The Kafka consumer into PubSub is where we do a lot of that initial filtering, so we don't have to pay for essentially stuff we don't need. We also, for the event stream, we also take out some fields that may contain like sensitive data for our customers, and due to like GDPR and stuff, we can't bring into BigQuery. So we do all that filtering between Kafka and PubSub, and then PubSub to BigQuery is where we actually make it look how BigQuery wants.
But you're not using Dataflow for querying Kafka. You're using some just microservice.
Yeah.
Why that? Same like a streaming solution, right?
Yeah. It seemed like overkill. I don't know. It was easy enough to do with just a pretty simple Python script. So.
Got it.
Yeah.
Thanks.
But you're paying a lot of money for PubSub from Google.
Yeah. Yeah. I mean, I do know that in the grand scheme of things for our entire GCP bill, it's not that big of a chunk, but we are paying for it. Yeah.
Did you run into any issues setting up CDC? Did it like increase the amount of load Postgres had to take on to like push these changes?
So I actually didn't write CDC. CDC was something that some people on our a team called Search and Storage wrote, because they actually want to use this to reconstruct tables in Snuba, similar to how they're bringing events into Snuba, because they're running into a similar issue. Like they want to bring, from what I understand, I'm not on this team, but they want to bring everything into Snuba as opposed to Postgres. So they developed CDC for their own use, but I found it useful. So I plugged into it for this project. Yeah.
First of all, thanks for your presentation. I like the two examples. You mentioned you were using SQL for one of your projects. Are you using like Beam SQL, or is this outside of Dataflow?
Yeah, this, because we ended up doing the, it's outside of, it's not Beam SQL. Yeah, it is happening in Airflow, most of it. Some of it is happening in like just materialized BigQuery views. So the SQLs actually run when the query is run. Yeah, it could probably happen in Beam SQL. That's a good idea. I should look into that.
Any performance issues you encountered using Dataflow or PubSub? Or
I'll touch it.
A lot of issues that Mike will talk about. This was like a complicated project. It was my first time working with Beam and Dataflow, so I'm sure like y'all have a ton of ideas. You probably could have gotten me out of many holes that I had dug myself into. But yeah. Shoot.
Yeah, I was curious if you used for Beam Dataflow, if you used Java or Python SDK. Python, what kind of issues you might have run into?
Many issues on Python. I believe Mike is also covering this. We started with Python and we ended up using Java.
Stealing my thunder here.
Did I see a hand earlier? Yeah.
What is the PubSub? What is PubSub?
What is PubSub?
Yeah.
Yeah, so PubSub is on a really high level similar to Kafka. It's just a queue. Like you can throw data into it and then you can pull data out of it. It can also push data out of it, I think. I don't think I've ever used that, but yeah. It's just Google, it's a Google product.
What do you guys use to track error in a pipeline? If something goes wrong in a pipeline state, like just use stat driver or something, or?
Mike is also kind of going to talk about that. We want to use Sentry. Yeah.
When you use since you use BigQuery and SQL is very slow, any reason why you didn't go with Elasticsearch or something like that instead of the BigQuery?
We use BigQuery for pretty much everything. So I think incorporating another tool in the mix for like analytics purposes would have been difficult, which is not to say it's impossible. I've never used Elasticsearch. Yeah, that's a good idea.
How about ClickHouse? I know you're using ClickHouse.
Yeah, ClickHouse is actually, read our blog post on Snuba. It's like, Snuba is also ClickHouse. I don't really understand how it works, but but yeah, that's what Snuba is.
Okay.
Yeah.
I can touch on that.
Yeah.
We use ClickHouse for online processing mostly, and potentially we could consider for analytics. We be a different use case, different operational implications, because now we use it on a relatively long lasting for online processing. That's it. But potentially it could be.
Do you have a chance to compare ClickHouse to BigQuery at all?
No, because they serve different purposes. For ClickHouse, we use it strictly for online processing. So simple query, generally simple queries for that are responsible for milliseconds. So it's not the same kind of use. So comparing the two.
Also, it's good to know that when we think about the BigQuery, a lot of different data streams go into the BigQuery. So it's not only this data stream going there, right? So BigQuery, our usage of BigQuery for the analytics perspective, it's much wider than what we're talking right now.
Totally.
For ClickHouse, it's a very specialized in a certain way to serve our products, right? It can certainly be used for analytics, but it's harder to have all the data streams going to ClickHouse and going to
Different instance of ClickHouse, for example?
yeah, that's certainly not.
Yeah.
Cool. Yeah.
I was running a pipeline once to BigQuery, and pretty much what I was doing is just getting like the most recent view of some data. And I ran into some issues regarding like BigQuery like staging, and getting errors around, or when I was looking at the BigQuery tables that like weren't updating like real time.
Sure.
Is that something that you guys have run into?
So I know BigQuery has like a streaming buffer.
That's it.
So if you like click, you know, on the like left hand side where it lists your tables,
Yeah.
if you click and you hit like preview or whatever, it won't show anything because everything's in the streaming buffer. But if you actually query it, I think those rows should show up. Yeah. Like if you actually run a SQL query over it, it will, but it just hasn't like cached them. I don't know what it does, but.
If it's a partition table, you want to look in the null partition value, because I think that's where it buffers it last I checked.
Interesting.
Yeah, I had the same issue.
Gotcha. Thanks.
Cool.
Do you have any ordering issues using PubSub?
We thought about that, and that's when we were thinking about doing a DDL solution, actually applying these updates. Before we realized that BigQuery had such strict limits, that was one of my concerns, because BigQuery doesn't have strict ordering. It's like they like kind of like wink wink say stuff should appear in order, but like what does that mean? So we thought about that as a concern. However, like with the solution we ended up going with, like picking the max timestamp, as long as stuff like, I mean, there's potential like if a row is delayed for like a long time, we might be wrong until that row shows up. That's just a risk. Yeah. We downstream, we actually keep an eye on the PubSub backlog to make sure that like Beam is consuming as expected. So there's certain things downstream that we're not gonna execute unless we can tell there's like not a huge backlog in PubSub. But otherwise, that's kind of our best assurance that we've received like all the data.
So you have a separate process for that, checks?
Yeah, we first, this might be getting too into the weeds, but for these CDC partitions, because it ends up being such a big query to reconstruct, like find the max timestamp over all time, what we do is we actually have a nightly Airflow job that creates like a end of the day view of the table, like materializes like at the end of the day what this looks like, and then we only have to use the actual like streaming CDC changes to reconstruct like between those times, if that makes sense.
Yeah.
So when we create that end of the day partition, we need to really make sure that we've like reasonably received all the data for that partition. Otherwise, this stuff gets bad.
I see.
Yeah.
Thanks.
Yeah.
It does help that because it's going through Postgres in this case, that's serializable and it's keying off the wall logs, right? So that we can take advantage of that ordering, the strict
Yeah,
ordering
that's
within
true.
Postgres
That's true.
to set a timestamp that we can trust downstream. So that's what
And I am bringing, the Kafka offset into BigQuery. So if we need to know strictly like in what order these happened, I can use the Kafka offset to do that. Yeah. Yeah.
One more question. Are you using any like message schema like Avro or something during transmission?
No. Avro is like a file type, right? Like if we wrote to GCS or something. I don't know what Avro is.
No, you can transfer messages in Avro format. It's just a byte array.
Okay, I don't think I am, since I don't know what it is.
It does support schema, so it will be easier for you.
Oh, okay, yeah. Yeah, that's a good idea.
To create the schema and then to publish
Totally.
different BigQuery table.
Totally, that's a great idea. I'll look into that. That's a really good idea. Yeah.
I'm just curious if you have anything like if you lose your offsets on your Kafka consumer, like what would the downstream impact be?
Like if we lose track of where we are, like if for some reason the consumer gets messed up and we have to like reset it.
If it would have to replay all the messages. What
Yeah.
impact would that have on you?
I mean, I think from like worst case perspective, when we replay the messages, we're gonna have duplicates in the CDC table. So when we select for the max timestamp for each row, as long as we're selecting like distinct kind of to like make sure that we're only grabbing one copy of that most recent row, I don't think it'll be a problem. It might make the query more expensive if there's like a ton of duplicates, but yeah, I wasn't too concerned about that.
But what about for the second pipeline?
For the event stream,
Right.
yeah, that would be an issue. I'm also, for what it's worth, when I'm doing the aggregates, I am doing a select distinct on the event ID, so I'm not counting the same event more than once, or like count distinct event IDs that look like XYZ. So it shouldn't affect the aggregates. It would affect if we wrote queries without taking that into concern, I guess.